Cool. So hi everybody, and thanks Alex. I really enjoyed that. There's a lot of interesting things that I feel like I'm still lost on whether or not to put Turbofish like the colon or not when I'm writing Rust. I usually just like let the Rust compiler yell at me and hope for the best. But yeah, there's a lot of people. I mean, we're all being really quiet. There's lots of people from different countries here. I'm in Melbourne, Australia at the moment. So I mean, this is Melbourne right now, if anyone's curious. But can everyone just like say in chat what city you're in? I mean, I assume most people are in Auckland, but I'd be really curious to hear where everyone is.
Auckland? I'm from Auckland.
Yeah, cool. All right, we got someone from Bangalore, and Nick's in Auckland. Ooh, Singapore. Nice, Berlin. Cool. Wow, we've got a really international audience today. This is really fun. But yeah, nice. So I'm going to talk about something a bit different today. Let me share my screen. Sorry. Life is hard. That's why computers get harder to use every year. So I'm going to talk about real-time data in Rust. Can everyone see my screen? Is this looking good? I can never tell. Actually, I can't see anyone replying. I'm going to assume it's working. But before I get to that, it's my birthday today. So I turned 36 today, which is really exciting. And like funny timing. And every year whenever it's my birthday, I always feel like an old man, even though I'm sure I'm not the oldest person here. But I feel like I kind of like, it's my birthday, I can cry if I want to, or like make bad song references. So I want to like spend a bit of time talking about like some kind of history and philosophy. I'm sorry, I'm going to set a timer so I don't go horribly over time because I'm old now. So that's the thing that I do. Before I get into the real-time stuff, as I say, I want to talk about some like kind of history and philosophy and how I think about a lot of programming type things. So this is a photo of me when I was 8 or something as a kid. And like sometimes these days I've been thinking about like how old are you in programming years? So like instead of thinking about it from when I was born, because it's kind of arbitrary, how old are people here? Like I'm really curious. In the years from when you first started programming. So like if you were a newborn when you first started, like how old are you now? I'd be curious just to, I don't know, like hear a couple of people, sorry, Zoom, where did your chat window go? People just in chat how many years old you are. I'd be really curious to know. I'm quietly wondering if I'm the oldest person here in programming years, since I've been programming since I was about like 8 or 9, but yeah. Cool. 11, 23, yeah, 30, nice. Yeah, it's really great to see some people with a lot of experience. I've gone to a lot of JavaScript meetups, and those are always, including before uni, absolutely. Yeah. Yeah, 2 in Rust, that's pretty close to where I am as well. Yeah, it's interesting. Yeah, I've gone to a lot of JavaScript meetups, and it seems like the average age there in programmer years is sort of like about 5. It's great to see lots of like more experienced people hanging out in the Rust community. So yeah. Anyway, so that's super interesting. But yeah, I started programming when I was about like 8 or 9. So like maths is hard, but I'm 36 now, so I'm like 28 in programming years or something. And like I managed to find this program that I wrote when I was a kid. So this is written in QBasic, because that's the best language in the world, and all we got is Microsoft DOS. So this is a program that lets you like guess a number. The program thinks a number from 1 to 100, and it tells you like higher or lower. You can tell that that I was very good at programming. I had my beautiful variable names A and AA. I didn't understand what functions and subroutines were yet. So I mean, like there was no internet really. So I learned everything about programming just from like literally reading the help on every single function that was in the standard library. And then I would read what it did, and then I wrote a little program to try and use it in some way. So I didn't know what functions were because they weren't part of the standard library. So I ended up with this beautiful piece of gorgeous code using gotos. And sometimes I think about it like in these terms. Sorry, I'm just going to mess with this. Zoom chat window is now on top of my screen, so I can't actually see my own slides. I think about it like this. It's like in 1990 or something, 1992, there's me soldering and I was writing QBasic like that. And now it's 2020 and I'm using Visual Studio Code. Like this IDE here, obviously is not how I wrote QBasic at the time, which is written in JavaScript, which is really weird. And it embeds a whole web browser inside it to be able to make a native application, which is super weird, right? And like, how do we end up here? Like, I feel like with history, there's been a series of moments that have all mattered to get to this place. Like in 1996, the HTTP 1.0 spec was ratified. 2004, Gmail launched. So this is like the start of web apps existing. And like Gmail used XML HTTP request, which is one of the worstly named APIs in human history because there's nothing to do with XML, but that Microsoft invented for, I think, for Outlook. But so we've got Gmail, right? And this is like the start of web apps being a thing. And then fast forward to 2020, and we've got web apps slowly starting to like elbow out and edge out native applications for how we build software. But like one of the benefits of programming for so long is you start to be able to see history not as like, it's like, it's the most obvious way that you can think about the present is kind of as an inevitability. Like, of course we're here. Like, of course we've got computers. Of course we've got the internet. Like, of course that the internet works a certain way, a certain series of ways. But like, if not for Tim Berners-Lee, HTTP wouldn't exist. And maybe someone else would have invented it. But if they invented it, they would have invented something really different. So like, maybe we wouldn't have the web, but maybe we'd have something else. And it almost certainly wouldn't use HTTP. It almost certainly wouldn't use HTML, right? What would it look like? I don't know. I'm really curious, like what are in these other like past future histories that we didn't get to experience? Like, like maybe there's a timeline that we could have been on where file systems weren't invented, or or a timeline where everyone programs everything in Haskell. And like, that seems crazy to us programmers because Haskell's like, oh my God, so complicated. But we've accepted a lot of complexity that we teach all of our students as, well, this is just how computers are. And if the way that people think in something like Haskell or in Rust was the way that everyone was taught, it wouldn't seem complicated anymore. Like, to me, and I've worked in the web for a long time, HTTP is really simple, but there's actually a bit of complexity in there. And it seems simple to me because I'm used to the complexity. In the same way that, the idea that I've got an IDE written in Electron is for some reason reasonably simple idea to me now, even though it's kind of crazy. So like, there's also another way to think of all this. Paul Graham had a really great essay where he talked about the idea of 100-year programming language. So my take on this is like, like what in 100 years time, what will it be ridiculous that doesn't exist, yet? And then could we just make that thing now? Or to put it another way, if I went back to like 10 years and said, hey, I thought of this great idea and took back some of the ideas we have today, what would they be able to use? Or another frame is, if we want a programming language that's still going to be useful in 100 years time, that's still going to be popular in 100 years time. Like not everything that's made today is still going to be popular in 100 years. A lot of things are kind of an evolutionary dead end. Like nothing was invented on top of COBOL. That's, like that was the end of that. So, like, so what could that look like? He had this great quote, like, so we've got two ideas. If you combine them, they suggest interesting possibilities. Either a 100-year language could in principle be designed today and, and such a language, if it existed, might be good to program in today. But when you see these ideas laid out like that, it's hard not to think, why not try writing the 100-year language now? And like, for my money, I feel like Rust is very much an attempt at this. It's like making a language that we could still be using in 100 years because it's done a lot of things right. Or if it's not still used in 100 years, then whatever we are using in 100 years might be built on top of Rust. So, although obviously QBasic is going to be around forever. So this kind of takes me to the next part of the talk that I want to talk about, which is this idea of cultural abstractions, or like, like there's this beautiful image which I found on Wikipedia of retrofuturism. So the idea is like, like fictional alternate timelines that could exist, but like, what could that look like in programming? And I feel like there's a bunch of cultural abstractions that we take for granted. So we've got the idea of like you know, there's a separation between the hardware, the operating system, and this is just me brainstorming a bunch of different ideas. The hardware, the operating system, and then like applications that run on top of that. And then the applications are all isolated in some way from one another. Or like the idea of files, right? And we invented files a long time ago. So today when we use a database, the database sits on top of the file system. But if the database was invented first, it would probably be the other way around. Like it would probably be that, you know, in the operating system would it be some crappy simple database. And then our file system would be something that we ran on top of that database. But that's just like an accident of history. Like this is just the timeline that we happen to be in where it works like databases on top of file systems. We've got programming languages and libraries. It's really hard to, I can't see everybody. So I want to like, you know, like there's this question, like if anyone else knows the answer to where the word library came from or why we use the word library to talk about programming code. Does anyone know? You want to just type in chat if you know the answer? Give people a minute or two. Tobias saying file systems are on the way out with NVRAM. I'm not convinced of that, but that's a separate conversation. Give anyone a minute or two to jump in if you know what libraries refer to. So my understanding of this story, which is what I was taught, is that the word library actually came from Rear Admiral Grace Hopper, who's one of the people who originally championed the idea of high-level languages as opposed to writing everything in assembly. We use that word because she used to be a librarian, and she had this amazing image of being able to walk into a library, but instead of on the shelves be books full of fiction, instead on the shelves were pieces of computer code, functions and algorithms that we could just take off the shelf and then use in our own programs, instead of, as was the case at the time, having to write everything from scratch with every single program. So, I mean, arguably we should call them libraries or books, maybe, right? But that's where that term comes from in programming, which again is a total accident of history. If not for Rear Admiral Grace Hopper, like, I'm sure we would have had high-level programming languages, but we wouldn't think of them in the same way. And then we've got things like databases and SQL. This is a piece of history that exists, but there's a bunch of quirks about how they exist. Then things like HTTP, the web, and then the fact that we've got web applications versus desktop applications. Like, why is that how it is? How come I have to decide between these two different ways of making applications with seemingly arbitrary trade-offs? I mean, this is what a computer is. This is a photo of the Konrad Zuse's Z1. I was shocked to discover this when I visited Germany. I was in Berlin at the Technik Museum, which is amazing, by the way. And Konrad Zuse made the first, arguably the first programmable digital computer. And this is a replica of it. The original one was destroyed by bombs during World War II. He showed it to the government, and they said it was a toy. So he kept on working on it. And the warehouse in which he was building it was destroyed by an Allied bomb. And so they built a replica of it, although it hasn't worked since he died a few years ago. But from this computer, this is not obvious. So this is like SGML, and like, which just always makes my eyes bleed whenever I look at things like this. And I feel like it's like, this is like the 0.01%, timeline that we happen to be on, where this ended up being a way that we might send data to one another. So when I think about all of this, and so there's this beautiful quote by Alan Kay, which I think about sometimes with all this, where some people measure progress in answers right per test or tests passed per year. We're more interested in Sistine Chapel ceilings per lifetime. Like, the Sistine Chapel took multiple generations to make. So many craftsmen spent their life's career working on the Sistine Chapel, and it was never complete by the time they died. So the question isn't like, how many lines of code, how many features or bugs did you manage to fix last week? But instead, like, how many Sistine Chapels are you going to create during your lifetime of creation? So so that kind of gets me into this question of what's missing. And this is kind of how I think of my own career of, obviously we all want to be a model. So how do we add to this set in a way that would be like beautiful and adding to the, adding to the continent of, software that other programmers can then build on top of in turn. And to me, like, this is where this kind of real-time data stuff comes in. Like, I think a lot about like databases, and we got there. Databases and SQL and stuff. And I feel like there's this really important piece missing, which is the ability to interact with data in real time. So it feels to me like we've made this really quite nice stack of abstractions that let us be able to like interact with data at a batch level. So I want to be able to, you know, compile software, and I take the file on my computer, I run, you know, a cargo build, and then I end up with a binary. But if I want to make a very small change to that file, then I have to run cargo build again. And most of those steps happen again in their entirety. So the build process is really slow. Like if I edit a string in my file, that should be like, I mean, it's say like I edit 2 characters. Why do I have to recompile the whole file? And then why do I have to link the entire program again? Like arguably, like in terms of the number of actual instructions needed to be able to that change through to my binary, that should be tiny, it should be instant, but it's not. So like from a batch processing world, we've kind of got this idea of like, you know, if I'm making a web or a mobile app or something, we've got the file system, and then on top of that, maybe I'm running Postgres. So my Postgres is reading my file system. Then my application server is making SQL queries to Postgres. I've got my mobile app, and that's making HTTP requests. So it says, you know, get me this data, get back the, you know, HTTP response, and everything's good. But as soon as I introduce like real-time data, so for example, I want to make Google Docs, or I want to have a live dashboard, or anything where the data, you know, isn't completely static, I have this awful mess. So I've got my file system. Well, I can't do real-time reads from my file system. I mean, I kind of can using IONotify or something, but it's really janky. Then what I've got, I can use Postgres. I can either have like logical decoding plugins, or I could use Kafka alongside. If I use Kafka, then I've got to think about where the central source of truth is. I could use KSQL, but that's a pain. Zookeeper, like, what is my application then making SQL queries, or how is it going to update that data in real time? It's really awkward. And then once my application server understands that this data is changing, how do I send that changing data across to my application? And the answer today is that we go back to the bad old days of just writing custom protocols for anything. You know, like before applications use HTTP for almost everything, we would just do it on top of TCP. Everyone would just write their own TCP protocols for every program they were writing. You know, and like most games still do this, but like for most actual applications, we just use HTTP because it's clean and nice and it's got well-defined semantics. But if you want to do real-time data transport, like we can use WebSockets, but again, that's just TCP with a message frame around it, or GraphQL, which, you know, GraphQL's got some real-time stuff. I honestly don't think it's very good. So like, you know, and then I think about something like compilers, right? So like, I mean, this is what I was talking about. So today we've got RLS and things like it, but I can't get a binary out of RLS. Instead, I think RLS like exposes a web server, and then my IDE can query the web server while I'm typing, except then the IDE is still expected to do syntax highlighting itself. So every single IDE has its own syntax highlighting support. It all just seems like we're not using the right abstractions to me. So this is like why I've been building this thing called Statecraft, and I've been working on and off on it for the last few years. I haven't done any work on it for most of the last year because I've been doing commercial work that's made me actual money. But what I want to have is like a standard API for data that changes over time. So if you've got some data that changes, either we're using the Statecraft API to interact with it directly, or or there's a standard protocol over WebSockets or ROS TCP or something like that. And for what it's worth, I've been talking to the IETF people. So been wearing my IETF hackathon t-shirt from Singapore, where I went last year, and I've been talking to the HTTP working group about potentially adding like a standard protocol for some of this stuff in into the actual HTTP protocol. So like there's a standard way to be able to do this stuff on top of HTTP as a potential path forward. So like an example of where you might use something like this, I'm imagining, say, like, right now in the operating system in Linux or Mac OS or wherever, if there's data that changes inside the OS that your program wants to understand and listen to, right now, like what a program like HTOP will do is it just polls proxy. So every time, every second, it'll just read a bunch of data from the kernel via a file, and then, then reparse it and then try and expose it out. But what I'd love to see instead is, for example, all of that kind of data, just expose it out through something like Statecraft, where you say, get me the version of the data that exists right now, and then tell me anytime it changes. And then as it changes, then your application will get that data. Or maybe you'd say only tell me up, maximum once a second or something. And if something like the operating system kernel just did that across all of the data that it had that changes, it'd be so much nicer to work with, rather than like, polling and then like parsing these wacky text files that change every few kernel versions. Another idea, another kind of place I'd want to use something like this is to say like, something like a Google Docs, where, and I personally worked on Google Wave way back when. So this is like one of the reasons why I'm so interested in this stuff. I'm not sure if anyone remembers it, but yeah, it was like a attempt to replace email with a real-time document editing kind of experience. And, if I've got a text document in my database, I want to just be able to subscribe from my browser or WebSockets or whatever, and be able to get streaming changes, incremental changes, saying this particular character was inserted here. and then also be able to do real-time collaborative editing. So yeah, so what I've been building, or of course, like, use Statecraft all the way up. So if I had proxysfs, and then I could use the Statecraft API, re-expose it out over WebSockets or over HTTP subscribe method or something, if we make something like that, and then just consume that from a monitoring dashboard in the same way I could consume it locally on my own machine through the same API. Well, that'd be really nice. So I want to show you some of the stuff I've been working on, and I feel guilty saying this. I've been making a proof of concept in TypeScript, and then slowly over the last year or two, been porting it across to Rust. So the Rust code at the moment is not functional. I feel bad about that since this is a Rust meetup, but I feel like Rust is totally the right language for it to exist in the long run. But right now, most of what I'm going to show you runs in TypeScript. So let me show you what it looks like now, though. So I've got here a little server. And what the server is it's running a TypeScript server that does collaborative text editing. So, oops, are we going to work? Yep, great. So this is the ASDF document, and I can type in here, and can't tell anything's fancy. But if I open it up in a second window, now I'm seeing character by character my edits, right? Which is, I mean, that's great. It's not super fancy. It's not very exciting. I'm going to promise you, I'm not actually going to demo it, but this also does real-time collaborative editing stuff. So if one of the users goes offline, they type some stuff, they come online again, the other users type stuff, all the characters will be merged in a way that's completely consistent and works. But the fun thing about this is that because the API that the browser uses and the API that the server uses is all the same, I can also re-expose the same Statecraft server. I can connect to the same Statecraft server from a different kind of process. So remember, this is just like REST, right? The idea here is that we want to be able to subscribe to some data and then be able to get told when it changes. And if we've got the same protocol doing that, then just like REST, we don't have to use the same application to use it everywhere. So I've made a little, like, what I call my universal client for Statecraft here. So what this is showing me, this is doing a Statecraft subscription to the entire store. So I'm seeing the document here, and then if I go back to my browser and type in it, well, I'm just subscribing to the same document, so I can get the same edits. And we can actually see what those edits look like. There's a bug at the moment where it's also sending the entire replacement document every time I type anything, so just ignore that for now. The important thing, though, is this, where it says, this is the actual characters that were changed. This says at position 48, the characters K and L were inserted into the document. So if I select everything, delete it, I see at position 0, delete 50 characters, and then I can say, hi there. Oops, you can't see it. So we're getting like character by character, insert H, position 1, insert I, position 2, insert space, and so on. And we can also see this version number at the top here. So as each character is typed, the version number increases. And this is just monotonically increasing. And we can do some fun things with this. So like I could render this to Markdown. So this is just doing a transform on the document. And the transform itself is subscribing to the document. So every time the document changes, we're just rerunning the, rate limited, we're rerunning the Markdown rendering. So I can do something like that, or like, I can make a list and I can just see the HTML. Or of course, just render it HTML. So now I've got a live editor. And do things like that, which is really fun. And I also want to, and I've been burning through all this stuff really quickly. Does anyone have any questions on this before I show something else? Sorry, I speak really quickly, which I feel like is a extreme contrast with Alex. Sorry, now I've lost my Zoom chat. Oh my God, life is really hard. Here we go. Storing lots of records on tape. Thanks. Yeah, one of the nice things with something like this is we don't actually have to necessarily store all of the changes historically. We can just, like, using something like the same kind of way that Kafka does, we can say, right, I'm going to store a snapshot and I'm going to throw away all of the edits that are older than a week ago or something like that, which then lets anyone that connects from and be able to catch up. But okay, fair enough, that makes sense. But yeah, I guess we'll have more questions at the end. I'm going to show another little demo of this, and for this, I've got my little MIDI keyboard here. I can't play. I bought this because I wanted to learn and then totally failed at that job. It's got little lights, which is really fun. So I'm going to show another demo. So I'm going to kill my little text editing demo, and I'm going to open this up. So obviously we've got to wait for it to start because it's actually compiling TypeScript every time I run it. I'm going to just refresh that. And then I'm going to restart this. Mind the man behind the curtain. And then refresh this. So now this is actually seeing a document that is a document describing the state of my MIDI device. So it's a Focusrite launch key, and I can turn these little pots. And as I do, and ultimately what I want to have is a very minimal update here. But I can see the status of the keyboard itself. So as I turn this all the way down to 0, it goes to 0. I turn it all the way up and it comes up to 127, which is really nice, and spin a few of them. And also, like, if I push some notes, I can see the state of the keyboard itself exposed out as a Statecraft object. So now, right now, this is all done through the browser APIs and so on. But like, what I really want to have is something like a simple Rust process, and then the Rust process consumes the MIDI APIs that my operating system provides, and then exposes out a document describing the MIDI device. And from there, anything that wants to use MIDI can just use that as a library, as a service, as a remote service, expose it out somewhere so that we could have like a whole orchestra, like feeding all the data from all their instruments straight into a single system, whatever you want it to do. And then we can have like, all of the information about those devices. I really want to hook this up so that I can have, control the lights in my apartment or something like that from this, or control Lego trains and things like that. And lastly, I do want to talk a little bit about Rust. I feel like it's, important for something like this. For something like the text editing that I was showing you, so these text editing changes that you were seeing earlier, these are, what I want to have is like a very common standard. So you can say, this is what text editing changes look like. They say a position and what to change at that location. So I've ported that code across to Rust as well as C. And if you're ever curious about it, you can have a bit of a look. Sorry, my mouse is being really janky for some reason. So this is the text code that actually manages those changes in Rust. And for what it's worth, this is a project that I always use when I'm trying to assess a new language. So I port the same code and see how it looks. Interestingly, the Swift code of this, so I ported it to C, Royal C, JavaScript, TypeScript, Rust, Swift, and Go so far. The version in Swift looks almost identical to the version in Rust. The version in Rust is, we can, if you're ever curious and want some be able to flex, the version in Rust ended up being about 300 lines of code. The version, too much stuff open. The version in C of the same code ended up being about 750 lines. And the version in Rust maintains the same performance as the C implementation. The C implementation runs about, I think it's about 50 times faster than the JavaScript version last time I benchmarked it. And the big reason why it's so much nicer and cleaner is because of parameterized types. So what we've got, the way that the text system itself works is that every operation is defined as, where is it? Actually, I'm not going to find it. Every operation is defined as a list of these components. So every component then says skip 5 characters, then delete 3 characters, then skip 3 more characters, and then insert something. You'll notice here I'm using inlineable string instead of the built-in Rust string implementation. Almost all string edits, whenever we're doing collaborative editing, it's usually just a single key press. So having a pointer out to another object in heap memory, which then in turn stores some memory, is just inefficient, given that the pointer itself is usually larger than the string itself. So so there's an inlineable string crate if you're ever looking for something like this, which is much higher performance for small strings, because if you have a string that's smaller than pointers, so 64 bits, 8 bytes in on my computer, then that string itself will be inlined. And if it's too big, then you don't have to, the API is identical, so you don't have to worry about the difference. And then of course we can just iterate and use match to be able to describe a bunch of different parts of the operation change. So this then describes a type. So the type says that, because of course we don't want to, and the reason why we need this, which I kind of skipped over, we don't want to have to actually send, if we're implementing Google Docs or something like it, we don't want to send the whole document with every key press, because if we did that, then, it would be really inefficient for one, and secondly, we wouldn't be able to merge changes of multiple users together, because we'd have to try and do diffs to try and figure out what actually changed. So it's much better to encapsulate the change the user was actually expressing into what we call an operation, and then send the operation across. And then when we're subscribing to a document from the server, the document can also use the same operation syntax to say, here's a change, here's a change, here's a change. And those operations can then be ingested and applied locally. So yeah, which is, I mean, quite, I'm skipping over a lot of details. I'm doing that for time. So feel free to ask for more details during the Q&A if you're interested. Sorry, I'm just keep on looking at time. So the other thing I've been working on is how to actually express a server like Statecraft in Rust. And in Rust, one of the reasons why I've been procrastinating with this a little bit is because I've been really hoping that a whole lot of the stuff around async gets standardized. But what I've got here is I've got a simple store. And so we've got a read store implementation. So we've got a single value store, and a single value store is a store that just has a single value in it, which can be updated and changed over time. And what I want to be able to do is say, I want to fetch the store, so fetch a copy of the store, which will just return the value. Or later, if the store changes, I'll be able to get a subscription to those values in the store. There's a weird, I don't know if anyone else has read a great article called What Color is Your Function? And the article is kind of poking fun at JavaScript, saying that we've got red functions and blue functions, blue functions being synchronous functions and red functions being async functions. Now, blue functions can call red functions, blue functions can call blue functions, red functions can call any kind of function. But if you write all your code using red functions, i.e. async, no blue functions can call directly into your code because your code runs asynchronously. And Rust is slowly, this is one of my criticisms of implementing, like one of the problems I found doing this, Rust is slowly becoming like having the same problem, which is to say that I can implement this using async completely, but then unfortunately any code that just works purely via threading, well, it becomes really awkward to use this kind of thing from that place. So yeah, anyway, so these APIs are still very much in progress, but my goal here is to be able to have a library where you can take any variable, any value in Rust, be able to expose it out and say, expose this over the network or via the Statecraft API, and then be able to consume it from a browser, consume it from another process, consume it over TCP via another application written using the same Rust library. So yeah, so that's my goal with all of that. So I think that's about all I've got. I was one or two other things I wanted to mention just in terms of other things that we could do with this that are really exciting. So oh yeah, so this is what's happened when I was actually showing you that text demo. So I've got, I'm sorry, I can't, my mouse is invisible. I've got a database with my little wiki server, and then Chrome was connecting directly to it for me to be able to see the text editing. And then I was using Statecraft over TCP to be able to subscribe to it from my debugging server, which was then running another web server, and then my Chrome debugger was connecting over Statecraft to that. So yeah, just looks really complicated, but from an API perspective, I'm just consuming and re-exposing the same set of APIs. And yeah, ideally in the future, what I'd love to have is something like an IDE. So I want to have a file system, I've got a document server, which is just watching the file system for changes. Then my IDE interacts with that to be able to edit those documents, so my Rust source code. And then a compiler could then watch those documents themselves, character by character, tell the document server all of the syntax changes so that my IDE doesn't have to care at all about the syntax of the language. It's the compiler itself that's doing the work of telling my IDE how to style my source code. And then also the compiler could live update a binary with the tiny incremental changes needed to be able to actually just like have the latest compiled version of my file, my program. So yeah, thank you. Thanks for listening. I hope this was interesting. As I said, it's my birthday today. I figured I'm not going to go super technical in terms of Rust, but this is what I wanted to talk about. So